Section 1.5, example 36, using substitution to evaluate a trigonometric integral. So use substitution to evaluate this. Right now we don't have much to work with. Earlier when we were working with the trig functions, we did have like the opposite in the numerator that we had in the denominator, so it worked out nicely there. But here we have to really go back into our trig days, like the days that we actually like sat in a trig classroom. What I want you to remember is our double angle identities. Let's do a little recall or recap of our double angle identities. So double angle identities, more specifically, the cosine. So there are two that I want you to remember. So remember cosine of 2a was equal to 1 minus 2 sine squared a. And also there was another one, there was cosine of 2a. Well, there were like a total of 3 of these. But for this one, we're gonna just work on this. So cosine squared a minus 1. So I do see, so here we have cosine squared theta. We could just turn these into thetas, no big deal. But I do see a cosine squared a right here. So let's solve for it and see what we end up with. So from here, cosine of 2, we'll say theta is equal to 2 cosine squared theta minus 1. So we have 1 plus cosine of 2 theta equal to 2 cosine squared theta. And to get that cosine squared theta by itself, we're just going to divide both sides by 2. So 1 plus cosine of 2 theta over 2. And there we go. All right, let's plug that in over here and see what we end up with. So integrating from 0 to pi over 2. Instead of cosine squared theta, d theta, we're replacing it with what we just proved. So 0 pi over 2. We have 1 plus cosine of 2 theta divided by 2 d theta. And now I'd like to say that we could just integrate like this, but we have that 2 theta here. So just for that simple integral, let's do a little something here. So pi over, oh, actually. So here we're gonna let u equal to theta. So du is equal to 2 d theta, or 1 over 2 du is equal to d theta. All right, and at that same time, we're going to have to fix those integrals too. So 0, when we plug 0 in here, it ends up just being 0. So that's nice. When we plug pi halves in there, so pi over 2, the 2's divide out. So this ends up just being pi. So integrating from 0 to pi instead of from 0 to pi halves. And now everywhere we see a 2 theta, we're going to replace it with a u. So 1 plus cosine u over 2 du. Now we have something that we could integrate really easily. Let's separate those two. So integral from 0 to pi of 1 over 2 plus 1 over 2 cosine u du. And just integrate. So integral of 1 over 2, or the antiderivative of 1 over 2 is 1 over 2 u plus 1 over 2. The integral of cosine is sine u. So derivative of sine is positive cosine, so we would just leave it like that. We don't have to multiply by a negative or anything. And we're integrating all of this from 0 to pi. So we're going to evaluate it at pi first, and we're going to evaluate it at 0. So 1 over 2 pi plus 1 over 2 sine of pi. So we have that, and we're subtracting at 0. So 1 over 2 times 0 plus 1 over 2 sine of 0. All right, let's see what we have. So pi over 2 sine of pi over here is going to be 0. So plus 1 over 2 times 0 minus 0 minus sine of 0 is 0. So our solution is just pi over 2. Just make sure. It looks like I might have made a mistake. Let's trace it back up here. So remember when I said 1 over 2 du is d theta, we were going to multiply by that 1 over 2. So let's just multiply all of this by 1 over 2. This would be multiplied by 1 over 2. Same thing over here. 1 over 2. So wouldn't be this, be 1 over 2 times that pi over 2, which is indeed pi over 4. There we go. That's the right solution. And it's important to note that I'm not perfect. I'm sorry. But I'm glad I made this mistake on here so you guys could see, maybe pay a little bit more attention than I am right now. So if you have any questions, please feel free to ask. Otherwise, bye.